All right, welcome back. Today, we're diving into a story from the world of mathematics that honestly sounds like it's straight out of a movie. We're talking about a problem that was considered totally impossible, like fundamentally unsolvable for 200 years. And then, someone might have just solved it. So let me just kick this off with a question for you. What if a rule, a fundamental limit in math that pretty much everyone accepted as fact for 2 centuries, was suddenly, well, not wrong, but just incomplete? What if a door that was locked and bolted shut has just been kicked wide open? Because that's the claim we're looking at today. Okay, so to really get how big of a deal this is, we've got to go back to the beginning. We need to talk about why this door was considered locked in the first place and how it created what seemed to be a permanent dead end in mathematics. Right, so the thing that locked the door is called the Abel-Ruffini theorem, all the way back in 1824. Now, in simple terms, it proved that while you can find a nice, clean formula for equations up to the 4th degree, the second you hit degree 5 or higher, it's impossible. There is no general formula using the standard tools, things like square roots or cube roots, what mathematicians call radicals. For 200 years, that was it. Case closed. And this timeline really puts it all into perspective, doesn't it? For almost 200 years, from 1824 all the way to 2023, mathematicians just had to work around this. They couldn't get perfect, exact answers, so they had to settle for close enough. Then, in 2023, Murad Sultan Ezouidi shows up and, according to our source, basically reopens that door. So what did settling for close enough actually look like in the real world? Well, it meant relying on methods that were, at their very core, just a super sophisticated form of guesswork. You see, in math, the goal is almost always precision. You want an exact, perfect answer. But because of Abel's theorem, the reality for these complex problems was settling for what are called numerical approximations. Just think of it like this. You want the exact value of pi, but you have to settle for 3.14. Yeah, it's close, but it's not the real thing, is it? And here's the crucial point. These workarounds had some serious flaws. They could be numerically unstable, which means a tiny change in the equation could give you a wildly different, completely wrong answer. They introduce rounding errors that can build up and throw everything off, and by their very definition, they were never truly exact. So finding a new solution wasn't just some fun academic exercise, it was a real necessity. And that brings us to the breakthrough. And this isn't a story about someone breaking an old rule. It's about someone creating an entirely new game. This right here is the key idea. The source material makes it really clear that Murad Sultan Ezouidi's method doesn't prove Abel's old theorem wrong. Not at all. Instead, it just bypasses its limitations completely. It finds a whole new path to the solution that the old rules didn't even know existed. I absolutely love this analogy because it makes the whole concept crystal clear. Abel's proof about the limitations of wood, it's still 100% correct. You cannot build a skyscraper using only wood. But what Ezouidi did was like inventing a brand new material, steel. He brought a new mathematical toolkit to the table that makes that old limitation totally irrelevant. So, how does this new method actually work? Now, we're not going to get bogged down in the super heavy formulas, but the concept itself is a really systematic process. Instead of guessing, it starts by analyzing the deep, hidden patterns inside the equation. It uses some pretty advanced tools to methodically break the problem down and then rebuild the exact symbolic answer step by step. Think of it less like throwing darts at a board and more like building with Legos. Every single piece fits perfectly to create the final structure. It's architecture, not approximation. And now for the main event. Let's put these two approaches head to head, side by side, to really see just how massive this shift is. And wow, when you lay it all out like this, the difference is just stark. Where the classical way just fails for equations of degree 5 and up, Ezoudi's theorem claims to solve any degree. Where the old methods gave you approximations that were full of potential errors, this new method gives you exact, perfect expressions with literally zero error. It's a fundamental jump from a limited tool to a universal one. And here it is. The proof is in the pudding, right? The number 19. Ezoudi's theorem was reportedly used to find the complete, exact, symbolic solution for a 19th degree polynomial. I mean, that's a task that for 200 years was considered fundamentally, axiomatically impossible.
So, what does this all mean? Well, it means a door that was shut for centuries isn't just a little bit ajar, it's been blown clean off its hinges.
So let's just recap the big takeaways from this incredible claim. What does this new key unlock? Well, it suggests we can now solve these unsolvable problems with perfect precision. This could have huge implications for fields like physics, cryptography, and engineering, places where these equations pop up all the time. It gets rid of the need for flawed guesswork. And, get this, according to the source, it even outperforms modern AI systems that still really struggle with these kinds of complex, unstable problems. You know, this quote from the source really gets to the heart of it all. This isn't just about crunching numbers. It's a philosophical statement. It's about how we approach problems that we truly believe are impossible. It suggests that sometimes the solution isn't about breaking the rules, but about finding a completely new way to play the game. And that leaves us with one final, really powerful question. If this long-accepted impossibility has been overcome, what else is out there? What other doors in science, in engineering, and maybe even beyond are just sitting there waiting for someone to invent a new kind of key? It's a pretty profound thought to end on. Thanks so much for joining me.